So we're going to go over some of the algebra review, part A. All of this you should have seen in the past, but this is just a reminder here. So the first one, 1, 2, and 3 says solve the inequalities. Inequalities are less than or greater than signs, something that's not equal. And then graph on a number line. A number line is exactly what you see down here. It's a line with numbers. So the things you got to remember is right here in this red box, and I kind of just highlighted what is greater than, what is less than, greater than, less than, greater than or equal to, less than or equal to. And then when we get to the number lines, we're going to graph it. We're going to point to all the correct answers with arrows. Okay, so let's go to number 1. You're basically going to solve this as if it's an equal sign here, number 1. And so if you see a -5, you add 5. And you put down 2x, the 5s would go away. -1 plus 5 is 4. Now you want to keep the sign pointed the same direction. If it starts off greater than, keep it pointed greater than. Then, of course, we're going to divide by 2. Divide by 2, so 4 divided by 2. Let's do this in red. Divide by 2, divide by 2, and 4 divided by 2 is 2. And again, you want to keep this sign the same. There is a time when you need to flip that sign, and that is when you multiply or divide by a negative number. Okay, so whenever you multiply or divide, if that was like divide by -2, divide by -2, then you would flip that greater than sign to a less than sign. But in this case, it was a divide by a +2, and so you don't need to reverse the sign. But keep this in mind here in red. You reverse the sign when you multiply or divide by a negative. Okay, I'm going to erase that because I need this room here. So now they're going to ask you to graph it on a number line. So there was a line here, and I just set up some numbers, 0 in the middle, and then +1, 2, 3, 4, 5, 6, 7. We are going to graph any numbers that x would be greater than 2. So what you want to do here is greater than 2. You want to make an open circle. That means right at 2, put in an open circle and point to all the numbers greater than 2, 3, 4, 5, 6, 7. And basically, this is all the answers. I can pick any number in this range here in red. And whatever that number is, if I plug it back into the original equation, it's not going to be equal to -1, but it would be bigger than -1. So for example, if I take the number 6, 2 times 6 minus 5 should be greater than -1. 2 times 6 is 12 minus, and then 7 is greater than -1. So any of these answers in this region here, pointing up into a million, a billion, is going to make the left side greater than -1. Okay, and then you would do the same for 2, 3, and again, remember to reverse the sign when you multiply or divide by a negative. Keep this chart in mind, which way the answers go, this chart here in green. Okay, we're going to go to number 4, 5, and 6. We're going to simplify the radicals. Simplify the radicals means don't go to a calculator and turn it into a decimal. What you're going to do is like this 45, you're going to break it into what times what is 45? Well, that's 9 times 5. Now the 3 on the outside, just leave it there because that's a perfect number. We don't want to break down the 3. Inside again, the 9 can be broken down to 3 times 3. Don't lose that 5. So 3 times 3 times 5 is still 45. Anytime you double up, hopefully you remember this, it goes to the outside. That represents a perfect square because the square root of 9 is a perfect square. It is the number 3. So anytime you double up like a 3 and a 3, you take one 3 to the outside. Don't lose the one that was already there. And anybody that's single stays on the inside, so that 5. The 2 numbers on the outside get multiplied, so this should be 9 radical 5. And that should be your answer for number 4. So try 5 and 6 now. Moving on through 7 through 12 here, this is the factoring. And there's 2 versions of factoring. 7 through 9, you look for a common factor. And then we'll talk about 10 through 12 again. This is what we call binomial times binomial. This one here for number 7 here, we want to break this down where it's a number that's the same, a common factor. You're going to multiply that with parentheses times parentheses. So you've got to look at the 6x and the 15. What number can be factored, can be divided out of both? And in this case, you can divide the 6 by the number 3 and the 15 by the number 3. So what you do with that 3 is put it right up front. You don't need to show this work here, and then you think about this for a second. If you have a 3 in the front, 3 times what will give me the front 6x? 3 times what in the back will give me the minus or the plus 15. So if you think about this for a moment, 3 times what will give me 6x, well, that would be 2x, plus 3 times what in the back will give me 15, that would be 5. And this right here is your answer, 3 times 2x plus 5 in parentheses. This is called factoring because you split it into the multiplication of parts. Now for number 7, you can see I took out a number. Number 8, you could take out letters as well, a common letter like x and as well as numbers. Okay, 10, 11, and 12, this is factoring where you split it into the multiplication where it's a binomial. Bi means 2 times a 2. So this is like a 2-part times a 2-part. So I've got my 2 parentheses set up. You're going to be multiplying, splitting it up, excuse me. This would be y and y, which would give me y squared. And this is the one where you go, okay, well, what 2 numbers multiply to negative 16, and the same 2 numbers add up to 6. And so you play around, well, what 2 numbers multiply to 16? Well, there's 8 and 2. One has to be positive, one has to be negative, and they both have to add up to positive 6, and those are the ones that work. So positive 8 minus 2. And this is a binomial times a binomial, and that's another version of factoring. And finally, just a review of graphing linear equations. Of course, that means a straight line. Number 13 here. First thing you want to do is always make sure y is by itself, and that would be in the slope-intercept form. Y is equal to mx plus b. The number that's multiplied with x is the slope, of course, and the tag-along number is where it crosses the y-axis. So in this case, y is by itself for number 13. The slope is 2, and that really means 2 up, 1 across. And this is the y-intercept at 3. And so the first thing we do when we want to graph this line is graph this 3. I'm crossing the y-axis at 3, so I would go, this is a hard graph to see, but there'd be a dot right there. And so we know that this line is going to pass through this dot some way. Now the slope is going to determine which way does it go. Now I just threw out a bunch of lines, but we know for sure it's going to pass through that dot 3. Now from there you move with the slope. Slope means rise going up and down over run. This is a positive slope. Positive slopes go this way. It was a positive 2. If it was negative 2, it would go down this way. But again, this is a positive slope, so we're going to erase this stuff here. And you're going to count with the positive slope 2 up, 1 across from 3, not from 0, 0, from 3. Up 1, 2, across 1, and then plot another point. Up 2, 1, 2, across 1, plot another point. Up 2, across 1. That is the slope. 2 up, 1 across. And then if I have a ruler, and I don't have a ruler, but you would basically draw this line right here. Whoops, I missed that. But that is the equation of this line. Y is equal to 2x plus 3. So get y by itself. If it's not by itself, get it by itself. Plot the y-intercept, and then move with the slope.